Beyond your DNA, how your lifestyle rewrites your genetic destiny. Welcome to Exploring Grays, the YouTube channel where we dive into the murky waters of ethics in technology and society. I'm Michael, and I'll be your guide through the complex world of moral ambiguity. What if everything you were taught about genetics is only half the story? What if your DNA isn't your destiny, but more like a first draft that's constantly being edited? Meet Sarah and Emma, identical twins with the exact same DNA. Sarah exercises regularly, manages stress, and eats a plant-based diet. Emma works 80-hour weeks, smokes to cope with stress, and survives on processed food. By age 50, they look a decade apart. Sarah is healthy. Emma has type 2 diabetes, high blood pressure, and shows early signs of cognitive decline. Same genes. Dramatically different outcomes. The science of epigenetics explains why, and it's revolutionizing how we think about everything from disease prevention to intergenerational trauma. In the next 15 minutes, you'll discover how your daily choices are literally reprogramming your genetic expression, and why this field might be the most empowering scientific breakthrough of our lifetime. The word epigenetics literally means above genetics. While your DNA sequence remains relatively fixed throughout your life, a complex system of molecular markers and switches, your epigenome, determines which genes get expressed and which remain dormant. Think of your DNA as a vast library of books. The epigenome is like a librarian who decides which books get opened and read, and which stay closed on the shelf. Same books, different reading patterns, completely different story. These epigenetic modifications happen through several mechanisms, but the most studied are DNA methylation, histone modification, and non-coding RNAs. Don't worry about the technical details for now. What's important is understanding that these modifications can be influenced by your environment, diet, stress levels, exercise habits, and even your social interactions. Slowing down to examine real-world implications. Let's take a moment to grasp just how profound this is. For generations, we've been told that our genes determine our fate. If heart disease runs in your family, you're likely to get heart disease. If your mother had breast cancer, you're at higher risk. While genetic predispositions are real, epigenetics tells us that these genes often need to be activated to cause disease. And we're discovering that we have remarkable influence over that activation process. This completely changes how we should think about genetic risk factors. They're not guarantees, they're possibilities that can be influenced. Let's look at some real-world examples that demonstrate the power of epigenetics. The Dutch hunger winter of 1944-45. Children whose mothers were pregnant during this famine showed altered epigenetic patterns even 60 years later, with higher rates of obesity, diabetes, and schizophrenia. The Överkalix studies. Men who experienced food abundance during their preteen years had grandchildren with shorter lifespans, regardless of what these grandchildren ate. Their experiences changed how their sperm developed, affecting future generations. PTSD studies of Holocaust survivors. Researchers found altered stress hormone profiles not just in survivors but in their children, suggesting that trauma can leave an epigenetic imprint that passes to the next generation. When I first encountered this research, it fundamentally shifted how I view my own health and choices. My father died of a heart attack at 52, and I always assumed I was destined for the same fate. The genetic risk is certainly there. But understanding epigenetics gave me a new perspective. His habits, chronic stress, poor diet, minimal exercise, likely triggered the genetic vulnerabilities we share. By making different choices, I might be able to keep those same genes dormant. Every meal, every workout, every meditation session became more meaningful, not just for my current health, but for how these choices might be reprogramming my gene expression. The implications of epigenetics extend far beyond personal health. This field is transforming multiple areas of science and medicine. 1. Cancer treatment. Researchers are developing drugs that target epigenetic modifications in cancer cells, potentially reversing the aberrant gene expression that drives tumor growth. 2. Aging research. Scientists have identified specific epigenetic changes associated with aging and are exploring ways to reset these markers, potentially extending both lifespan and health span. 3. Behavioral conditions. Studies suggest conditions like addiction may have epigenetic components, offering new avenues for treatment that go beyond traditional approaches. 4. Preventative medicine. Doctors can now test your epigenetic patterns to identify silent disease processes years before symptoms appear, allowing earlier intervention. But perhaps the most profound implication is this: your lifestyle choices today could affect the health of children you haven't even conceived yet. I find myself wrestling with a strange new sense of responsibility in light of epigenetic research. Each choice I make, from what I eat to how I manage stress, isn't just affecting me in the moment. It's potentially reshaping how my genes express themselves for years to come, and possibly influencing future generations. It's both empowering and somewhat overwhelming. If my grandmother's exposure to pollutants decades ago might be influencing my health today through epigenetic inheritance, what responsibility do I have to future generations in my daily choices? Many of you commented on our last video about DNA testing with questions about whether genetic predispositions are absolute destinies. Epigenetics offers a far more nuanced answer than traditional genetics alone. I'm curious. Has anyone in our community experienced significant health changes through lifestyle modifications, despite having a family history of certain conditions? Share your experiences in the comments below. Let's visualize your epigenome as a complex control panel that sits atop your DNA. Different environmental factors act as hands adjusting these controls. Diet quality adjusts the dials controlling inflammation genes. Exercise influences switches related to metabolism and brain health. Sleep duration and quality modifies settings for immune function. Stress levels adjust dials controlling hundreds of pathways. Environmental toxins can jam certain switches in the on position. Social connections influence settings related to stress response. Every day, you're unconsciously adjusting these controls through your choices and exposures. The global genetic surveillance landscape. Before we discuss the empowering aspects of epigenetics, we need to address how genetic information is being collected and used on a massive scale. While I discussed voluntary DNA testing in our previous video, several nations are now implementing mandatory national genetic databases that go far beyond commercial services. China has collected DNA from millions of people in Xinjiang, combining it with facial recognition data to create what some experts call a genetic apartheid system. Kuwait requires every citizen and visitor to provide DNA samples, creating the world's first completely genotyped population. The UK's national DNA database contains profiles of 7% of the entire British population, often retained indefinitely. Japan is expanding its medical research database with limited transparency about secondary uses. The proposed EU biometric database would create an unprecedented cross-border genetic information system. These databases often include family pedigrees, health records, and location data, creating a detailed picture that goes well beyond simple identification. The concerning part? Epigenetic markers can be extracted from the same DNA samples, potentially revealing information about your lifestyle, stress levels, and environmental exposures without your knowledge or consent. If your DNA tells the story of who you are, your epigenome tells the story of how you've lived, information that could be far more revealing than any standard genetic profile. Here's something fascinating that researchers have recently discovered. There are certain periods in life when the epigenome is especially malleable, windows of plasticity when environmental factors have outsized influence. Early childhood is one such critical period. The first few years of life establish epigenetic patterns that can persist for decades. But adolescence represents another key window, as does pregnancy for women. Perhaps most surprisingly, research suggests that the months before conception are critical for both potential parents. A man's lifestyle in the 3 months before conceiving can significantly affect his sperm's epigenetic patterns, potentially influencing his child's future health. This means family planning might reasonably include an epigenetic preparation period, where both partners optimize their lifestyle to create the healthiest possible epigenetic inheritance for their future child. The National Database Nexus. Understanding epigenetics becomes even more crucial when we consider how this information could be used by governmental genetic databases. Imagine a scenario where authorities can analyze your epigenetic patterns to determine your exposure to specific chemicals or pollutants, evidence of chronic stress or trauma, Dietary patterns that might indicate religious practices. Environmental factors suggesting where you've been living or working. This isn't theoretical. Research already shows epigenetic markers can identify smokers with 98% accuracy, detect alcohol consumption patterns, reveal exposure to industrial pollutants, indicate psychological trauma history. In the wrong hands, this information could be used for profiling, discrimination, or surveillance in ways that go far beyond traditional genetic analysis. Effort justification. Multiple perspectives. I realize we're covering complex material that challenges many established beliefs about genetics, so let's organize the different perspectives on epigenetics. The traditional genetic determinism view. For decades, we've operated under a largely deterministic genetic model. Your DNA sequence largely determines your traits and disease risks, with environmental factors playing a secondary role. The epigenetic perspective. Epigenetics suggests a more dynamic system where environmental factors can modify gene expression without changing the underlying DNA sequence, creating a biological mechanism for short-term adaptation that may even cross generations. The skeptical scientific perspective. Some researchers caution that while epigenetics is real, some claims about its influence, particularly regarding transgenerational inheritance in humans, go beyond current evidence and require more rigorous study. The integrative health perspective. Many integrative medicine practitioners have long argued that lifestyle profoundly affects health outcomes regardless of genetic predispositions. Epigenetics provides a molecular mechanism that potentially explains their clinical observations. Think about habits, health conditions, or trauma responses that have appeared generation after generation in your family. We often attribute these patterns to learned behavior or shared environment. But what if some component is actually biological, epigenetic patterns inherited from your ancestors? And what if, through conscious choices, you could actually break these cycles not just psychologically, but biologically? This isn't just about personal health, it's about healing ancestral patterns and creating a new epigenetic legacy for future generations. The choices you make today could quite literally change your family's biological destiny. In our next video, we'll be diving into the ethics of gene editing, playing God or saving lives? We'll explore the revolutionary CRISPR technology that allows scientists to not just influence gene expression through epigenetics, but actually rewrite the genetic code itself. We'll examine the profound ethical questions this raises. Is it right to edit genes that will be passed to future generations? Who should control this technology? And where should we draw the line between treating disease and enhancing human capabilities? I want to hear your thoughts on epigenetics. Has this information changed how you think about your daily choices? Are there specific health conditions in your family that you now view differently knowing about epigenetic influence? For those of you with a science background, what areas of epigenetic research do you find most promising or concerning? Share your perspective in the comments below. As we close, I leave you with this thought. For centuries, we've debated the influence of nature versus nurture in shaping who we are. Epigenetics suggests this dichotomy is fundamentally flawed. Nature responds to nurture. Nurture modifies nature. They are not opposing forces but partners in an intricate dance that spans generations. Your genes are not your destiny, they're more like possibilities awaiting your influence. What story will you write with the genetic narrative you've been given? This is the Exploring Grays channel, challenging black and white narratives around technology and ethics. Remember to question, consider, and think critically about the scientific discoveries reshaping our understanding of what it means to be human. Thanks for watching. Remember to like, share, and subscribe. Watch the next video pop up on your screen.